We are proving the second part of the fundamental theorem of calculus, which boils down to if capital G of x is equal to integral from a to x, so the input variable is the limit of integration of little g, and g is continuous at some point c, then g prime of c is equal to little g of c. So that's what I'm trying to prove down here, and this is how you set it up. And now I'm going to do a little bit of cleverness to make this thing nice. The first thing I can do, and I haven't told you what delta is, first thing I can do is I can rewrite these capital G's as the integral from a to x of little g minus the integral from a to c of little g over x minus c. I'm also going to rewrite this in a clever way. This is a constant. So the integral of anything over constant, if I were to integrate g of c over constant from a to x, right? So fixing x, integral from a to x of g of c is just going to be g of c times x minus a. So if I divide by, wait, I actually want c, sorry. So I'm going to rewrite g of c as the integral from c to x of g of c divided by x minus c. Because the integral of this is a constant times the length of the interval. You divide by the length of the interval, you get the constant. This simplifies down really nicely. Because this, if you do some algebra kind of like what I did up here, you get that this is just equal to, it's all going to be over x minus c, that's one advantage. This integral is going to end up being equal to the integral of from c to x of g of x minus the integral from c to x of g of c. Now I'm putting the x in there to differentiate from the c, but I can combine these integrals into one. I still am over x minus c, so now I get the integral from c to x of g of x minus g of c. So I've simplified this expression down a lot. And now I can just do some absolute value, right? I can take the absolute value of the numerator and denominator separately from c to x of g of x minus g of c. And going over here, the absolute value of an integral is less than or equal to the integral of the absolute value. C to x of g of x minus g of c over the absolute value of x minus c. Here I can use continuity. So what I know is that since g is continuous at x equals c, let's just even do this. Let's define the epsilon earlier. There exists a delta such that x minus c less than delta implies g of x minus g of c, I put parentheses there for some reason, is going to be less than, let's make it less than epsilon, I just need to think about how this is going to work it out. I think we can just make it less than epsilon. Sure, let's just make it less than epsilon. I think we could be really fancy here. Well, let's be really fancy. No, let's just make it less than epsilon. So, now, let delta just be that delta. Because now I get when you take the difference quotient minus g of c, go through all this algebra, you get this. This is going to be less than the integral from c to x of epsilon over x minus c. Epsilon's a constant, so the integral of the constant is epsilon times the length of the interval, x minus c, boom, boom, equals epsilon. So this quotient minus g of c is less than epsilon. We don't need this. So g prime of c has to equal g of c because this thing is less than epsilon. We're done.